Hello, my name is Pega. I'm soccer analytics researcher at Budapest Technical University. In this presentation, I'm going to show you a recent optimization model that could help the players, coaches, and soccer professionals in general to decide about the optimal action in critical situation of a soccer game. And by critical situation, I mean the moments that the ball holder player is under pressure from the opponents and he cannot continue dribbling the ball or passing the ball to the teammates. So his action space is now limited. He can only shot the ball or send the ball out of the field or commit a foul or perform an error action. An error action means that he just submit the ball to the opponents by defensive action of the opponent, such as the tackle or interception, or maybe some bad ball control from the player himself. Let's cut to the case. We are following three main goals in this work. First is how to deal with the high-dimensional tracking data and contextualize our analysis. You might know that the soccer datasets are separated into event dataset, also known as soccer logs, and tracking dataset. The event dataset includes some qualifiers for each of the actions that happened on the pitch, such as the passes and shots and so on. But the tracking dataset includes exact XY coordinate of every player on the pitch. So we can also calculate the velocity and other metrics that are much more desirable for us to get the contextual of the game to be incorporated in the machine learning algorithms. Second, we are going to show how to represent the state in a complex situation of the soccer game. And third, we are going to show how to derive player behavioral policy in the critical situations and optimize it accordingly. The result of this paper was published in the IEEE Data Science and Advanced Analytics Conference in 2021. Our main contribution was first the novel state representation with the help of the Markovian decision process. Next was the novel pressure measurement models and contextualization with the help of the spectral clustering on the opponent players. Next, we used the CNN LSTM model that could produce the behavioral policy for us. Also, we introduced a novel reward function for each time step of the game that could contribute to the long-term goal scoring. And also we used the policy gradient algorithm in the field of reinforcement learning in order to get the optimum policy at each situation and each state. In order to represent the state, we just separated the features to the handcrafted features, which are common in most of the soccer analytics work, such as the angle to goal, distance to goal, and so on. And also we are going to present and introduce three novel features, which are the pressure on the ball holders in three different zones. You can see we just performed the spectral clustering on the opponent's players based on their location and velocity on the pitch. So you can see the first cluster, the blue cluster, are players who can immediately take the possession of the ball from the ball holder. The yellow cluster are players who can take the possession of the ball in the next few seconds, and the player in the third cluster, the red cluster, they cannot take the possession of the ball in the near future. And this is giving us some good indication of the pressure in each of these zones. In order to derive the behavioral policy, we take advantage of the CNN LSTM network. You can see the input of our model is one possession, which is the combination of the pressure features and the handcrafted features, and also the one-hot encoding of each of these actions. You can see the building blocks here, and the softmax activation function could help us to get the probability of the ending action at the end of the possession. So we can see, for example, for such a state representation and for such a situation, what is the probability that the possession will be terminated with a shot, or foul, or ball out, or error, which means losing the ball possession. And also we have designed a novel reward function that can give us some short-term reward that the player did, for example, by performing a foul or ball out at each moment. And we are going to show how it can contribute to the goal scoring in the long term. In order to find the optimal probability of performing an action in the critical situation, we have taken advantage of the policy gradient algorithm in the field of reinforcement learning by accumulating the discounted reward that I introduced in the last slide, and by updating the gradient of the network with the help of the policy gradient algorithm, we could just encourage the network to increase the probability of highly rewarding action in the future. So the highly rewarding action will be encouraged to be happened again in the future. For example, if the probability of shot in a specific situation is high and also is low, and also the reward is high, so in the future the player is more encouraged to perform the shot in the future. In order to evaluate the behavioral policy, we just use the ablation study, and you can see among the 4 spatiotemporal models that we trained, which was the 3D CNN and LSTM and autoencoder LSTM, and the CNN LSTM can give us the maximum accuracy and the lowest amount of the loss with some optimal number of the inference time and parameters that you can find it here. Now, in order to evaluate the optimal policy, we want to see how can we sure that this is the optimal policy. We just use the policy evaluation method, and among the OPE methods we use the importance sampling and doubly robust, which was applicable in our analysis. You can see the green line here, green straight line here, is the mean expected goal or mean reward during the all matches that we had in the data set. You can see the expected goal is around minus 0.1, some minus negative amount. And our trained behavioral policy, you can see this is the purple line, and after about 70 epochs it just converges to 0.45, which is great and much more better than the behavioral policy. And this is also same for the doubly robust method. Now we are going to you can see that also this is the same for the kernel density estimation as well. The purple KDE has the higher mean reward and also lower variance in comparison to the behavioral policy. Now we are going to tell you the 3 stories and 3 scenarios of the game that 3 goal happened on the game. You can see here in the first scenario, player A is under pressure from the player B, C and D, which are the opponents from the blue team. And what is happening that player A, because of this pressure, is committing a foul. But the optimal policy network suggests that there is a situation for him, there is possibility for him to shot, but he didn't do that. But the suggestion of the policy network, optimal policy network, is a shot, and he lost this opportunity in this situation. In the second scenario, you can see again the player A is under pressure from the B, C, D from the blue team. What he's doing is that he just lost the performance error action, which means losing the possession of the ball, and actually player D from the blue team is tackling the ball. And in the next second, player D shots, and the goal, they are scoring a goal. So the red team, the team for the A teammates, are conceding a goal. But the optimal policy network suggestion for player A is that he could perform a foul in this situation. So if he could perform a foul, maybe they could keep the possession, and the goal conceding, of course, they could prevent the goal conceding. And in the last scenario, you can see again player A is under pressure from the B, C and D and E from the blue team. What is happening is that he is again losing the ball possession because of the bad ball control. Then the B passes the ball to the D, D passes to the C, and C just shots, and the player, they are scoring a goal. But the optimal suggestion of the policy network for player A is that he could send the ball out here, so they could prevent the goal conceding in this situation. If you have access to the soccer logs and also the tracking data, you can follow our templates that we have located in this public repository, and you can reproduce our results. And do not hesitate to contact us in these email addresses if you have any suggestion or any question about this work. Thank you for your attention.